Let us continue the tooth thickness measurement. So this part is what we are doing is a gear measurement. Here we are measuring the different parameters of the gear. Basically one of the parameter is tooth thickness. So here we will be calculating width as well as depth of the gear teeth. Usually we will consider per gear. Totally there are 4 methods while measuring the tooth thickness. One is you can use gear tooth vernier calipers. So in the previous class the derivation on gear tooth vernier calipers has been done, and the gear tooth vernier calipers is based, just what you are doing is using a vernier calipers you will be measuring the width as well as depth of the teeth of the gear. The same thing here also. The first method is GTVC, gear tooth vernier calipers, and second measurement is constant chord method. Constant chord method. Already you know what is chord. Chord is it is a part of the circle. Whenever the contact will be on pitch circle diameter, the portion what you will get is a chord. So it will be something like this. So this portion is chord, what we will say. And then next number 3 is base tangent method. Base tangent method, and it is also called as tool span micrometer, or it is also called as flange micrometer. There are several instruments available for the gear tooth measurements. Among that one is gear tooth vernier calipers is one of the easiest way to measure a gear tooth. Also profile projector, you can also measure the gear tooth in profile projector, but the accuracy will go on increasing compared to one method to other method. If you measure using gear tooth vernier calipers, you can measure width and depth of only one teeth at a time. In gear tooth vernier calipers, we need to know how many number of teeth are there. So NM by 2, that relation is there. That is very important. And constant chord method, we are keeping the width as a constant. This portion is made as a constant in all the teeth and we will be calculating. Then base tangent method, just we are drawing a tangent. So this is for the base circle, we are drawing a tangent. It is just like an involute profile where one teeth is being cut and which is rotated, which is indexed, and to get other teeth. It is similarly how to produce a teeth using a mill cutter. The same procedure is base tangent method. There is another method, that is comparator method. Comparator method. So here we are using comparator which will give the measurement. Here there are two things, one is fixed part and another one is moving part. When you measure the gear teeth using comparator method, comparator or an instrument will be used. Just it will give some value. That value you have to correlate with theoretical calculation, and that comparator is also one of the base tangent method only. It was given by a scientist, and those things will be measured with theoretically and error will be determined, and this error should be minimum. And another one is there, it is addendum method. Addendum method is always not so accurate, since you have to place exactly on pitch circle diameter, or you have to place exactly on the crest of the gear teeth. Sometimes it is difficult, but addendum method is not so widely used compared to these 3 methods. The most effective method is gear tooth vernier calipers only. In the examination, depending upon the marks, you choose the method. If they ask question like this, with a neat sketch and explain gear tooth measurement, then you can choose any of the method. In that cases, you choose first method, it is gear tooth vernier calipers, and derive width and depth. It is very easy. Let us see the second method, which is constant chord method. The name itself indicates the chord is constant for all the teeth. So this is one of the cumulative measurement for all the teeth. In the previous case, gear tooth vernier calipers, only one teeth at a time is being measured. Here you can measure any number of teeth by keeping chord as a constant. The limitations of gear tooth vernier calipers is the parameters. It depends upon many parameters like number of teeth and pressure angle, that is phi, and module. So here the dependency is very less compared to previous cases. Hence this method will be used widely. And it will be giving almost for the all teeth, and no assumption of teeth will be required in this method. So let us see how to derive it. Whenever I say a gear measurement, what you are doing is you are just measuring the width and depth of the teeth. Two things will be coming into the picture. One is width and another one is depth. Let us see here how to derive an expression for width and depth. So here width is this, see, this is nothing but AB. AB is equal to 2 into AC. That's all. Here AC plus AC will be equal to AB. That's what we have written in the first case, width of the gear teeth. Then after that, what we need to do here is we need to calculate what is AC. What is AC? For that we have developed a triangle ACP. How we have developed? Initially, this is a base circle and this is a pitch circle, and that is a pitch line which is touching addendum or a crest. So what I will do is I will draw a tangent from this part to this part. So width. So I will be drawing a tangent. Before that, first I will draw two vertical lines. These two vertical lines makes the chord constant. This chord is constant, this part is constant. After insertion of these two saffron lines, then I will mark a point A where this line intersects the flank. Similarly, B, this line intersects the flank edge of the teeth. After that, I will be extending this line up to base circle. Then after this, I will draw a tangent A. In other words, tangent to the base circle which is touching A. Tangent to the base circle which is touching A. Why I am drawing this is, I don't know what is the pressure angle. If I want to calculate the pressure angle is available here. So this is a pressure angle. This angle just I will be transferring here. By trigonometric relations, this looks like an alternate angle. So this phi and this phi will be same. So this phi is replaced here. Then what is this phi? Pressure angle. How to calculate? I want AC. You can use AP. PC, it is very difficult to calculate, hence that is not used. Consider triangle APC and find out AC using AP and phi. So that will be AP cos phi. So if I take cos angle, cos phi will be adjacent by hypotenuse. Here adjacent is AC, hypotenuse AP. So AC will be AP into cos phi. Then you need to find out what is AP. For that you need to consider triangle APD. Similarly, considering the triangle APD, calculate what is AP. AP you will get PD into cos phi. So sin of 90 minus phi cos phi. By knowing these two things, let us proceed for the further. We need to calculate what is PD. PD is nothing but it is the arc. PD is nothing but it is a PE. Then arc of PE is calculated. It is given by circular pitch divided by 4. That is the formula. Then after that, what is circular pitch? Circular pitch pi into pitch circle diameter divided by number of teeth. This is a circular pitch formula. In the terminology itself you will be knowing this. Then after that, what is PD? PD is equal to 1 by 4. Substitute the value. PCD by T is module, that is equal to M. Module is given by pitch circle diameter divided by teeth. And then AB is equal to 2 into AC. Substitute the values. 2 into what is AC? AC is AP into cos phi. What is AP? AP into cos phi. Then 2 into what is AP? AP is nothing but PD into cos phi. PD into cos phi. Again there is a cos phi. So this will get multiplied. It will be 2 into PD into cos square phi. Then what is PD? PD directly I will be writing pi into m divided by 4. 2 into pi into m divided by 4 into cos square phi. 2 1s are 2 2s are. Then it will be pi m by 2 into cos square phi. So this is AB. AB is nothing but it is a width. So this is an expression for width of gear teeth using constant chord method. Here the parameter dependency is less. It will depending upon the module. Module is, it is easily calculated. It is for cumulative teeth and it does not depends upon any teeth, number of teeth like that. So it is easy and it is accurate compared to gear tooth vernier calipers. After that we need to calculate what is the depth. How to calculate depth? Depth is nothing but it is the addendum minus PC. What is PC? This. PC is nothing but H. Total height is addendum minus PC. That is nothing but it is D. Depth. What is PC? Again here we have calculated. PC is nothing but AP into sin phi. PC the same thing, but here we have to use sin because it is on other side, opposite side. Then after that, what is AP? Substitute AP here. AP you have calculated. It is PD into cos phi. So PD into cos phi into sin phi is the term for that. And what is PD? PD you have calculated again here. It is pi m by 4. Same thing, pi m by 4. And this PD will be equal to pi m by 4. And replace this in equation D. You will get pi m by 4 cos phi into sin phi. Then what is D? D you have to calculate. Addendum is nothing but m and PC is nothing but pi m by 4 cos phi into sin phi. So any common factors can I take out? Yes, I can take out m as a common factor. If I take m as a common factor, 1 minus pi by 4 cos phi into sin phi. So this is a relation for depth of the gear teeth. So derivation looks like complicated, but it is all a basic trigonometric function substitution. So this is the depth of the gear teeth. While using constant chord method, this line is very important. This diagram correlation is very important here. First we will be calculating this, making constant width here. After this we will be drawing A, this line. A is a tangent for the base circle. That's all. So that is the only thing what we are doing here. Rest of the things are a small correlations. Next method is, it is base tangent method. The name itself indicates it is a tangent to the base circle. It is just like in the milling process, first one teeth is being cut, then after that by indexing mechanism we will be getting several teeth. So this will be indexed. Whenever you indexed, first let us see, for this base circle I will draw a tangent. So this is a tangent AC. Again I will rotate it. If I rotate that, it will be A1 B into C1, again A0 B into C2. So if I rotate, I will get this. So what basically I am doing is, I am involuting the profile. First I will cut a one teeth, then rest of the things by rotating, by indexing. What we have to calculate here, we have to calculate this part is a width here. So looking into the derivation, here the main thing is the tooth thickness is measured by measuring chordal distance. Again same thing, We are measuring the chordal distance, and chordal distance is over the teeth, over a number of teeth. That means not for a single teeth, for many teeth. How we consider many teeth is nothing but by indexing. Remember, it is in rotation. Once if you rotate, another teeth will be in contact with that. So A, B, C, A0, B, C2, A1, B, C1, everything will be same, because in the indexing we will get several teeth in contact with that line. Every teeth will be in tangent to that line. That is base tangent method. And here it is not only applicable to one teeth, it is applicable for number of teeth. Hence the name span comes here. Tooth span. It is not tool. Tooth span. We are using tooth span micrometer, that is for number of teeth. And stride generator ABC is rolled. As I already told, it is being indexed, rolled along the base circle. Then its end traces an involute profile. Involute profile, as I said, again the same thing. Because of which, since it is an involute profile, this condition holds good. What is this condition? AC will be equal to A1C2, it is equal to A2C1 is equal to A0 C0. So because of this, almost these arc lengths are equal. This is a condition because of tangent. By using the tangent condition of involute profile, we have written this. That is very important thing. Then next thing, arc length of base circle between origin and involutes, we have gear or teeth, and length of AC on pitch circle corresponding to S number of teeth. So because of which it is called as tooth span. Because of which it is called as tooth span. Then S minus 1 by 2 is just for one teeth. That's why minus 1 by 2 here. S minus 1 by 2 into pitch. What is pitch? Pitch you have to calculate there. And then angle subtended by AC. Angle will be, this is for one teeth, remaining 2 pi by n is for all the teeth. Multiply by 2 pi, that is for one revolution, 360 degree. One rotation, one indexing. Then arc BD, again arc BD is subtended, and you will be calculating the angle, again same thing. But here, since there is a subtended angle, here what we will do is, there is a shift between two things. This is a teeth and again this is a teeth. Because of this, what happens? There will be a shift. That shift is involute shift. The delta is nothing but it is an involute function, what we will call as. That will be exist when you shift, when you involute the profile. And it is a measure of, it is a function of a pressure angle. So just delta is said to be involute function. There is a separate derivation, but that is not there in the syllabus. Just you remember this, involute function will be tan phi minus phi. If you want to know what is the detail, that is available in the notes. It is just a simple thing. It is a small involute profile what we will take. When we take involute profile, a small distance will be unknown. That small distance will be calculating using a trigonometric relations. You will get this. And the advantage is this involute shift is there only in terms of pressure angle. That is a advantage. That's why we got this. And plus 2 delta. This is the angle during shifting, during involution. Then after that, substitute all the values. Substitute all the values. So BD, this is BD. Substitute all the values. Substitute all the values. S minus 1 by 2 into 2 pi by n plus 2 into tan phi minus phi into RB. What is this RB? RB will be equal to RP into cos phi. Radius of base circle. So this is RB, radius of base circle. This is RP, radius of pitch circle. The same thing what we have calculated here. For that also radius of base circle and radius of pitch circle into RB. What is the value of RB? RP into cos phi. Then RP will be equal to m into n by 2. What is RP is equal to n into m into n by 2 module into number of teeth. Same thing, D is equal to mz. D is nothing but R by 2 is equal to mz If you replace, you will get that equation. Then this is a final expression for the width of the teeth in terms of pressure angle. Here we don't want any shift here, that's why directly this equation is in terms of pressure angles. Again, the parameters are more here compared to this. Since the parameters are more, it is more accurate. In the first case, you will get only nm by 2 into sine something. In this case, you got another terms. It will go up to second order. Accuracy will be more. Most of the cases, base tangent method is useful whenever you want to find an involute profile. When you are calculating overall teeth, the width and depth, this method is helpful, but the derivation is somewhat long. Again, refer to the question, which is easy, you derive it. If they specifically ask base tangent method, derive this only. Derive base tangent method. Only one assumption here, based on tangent. Just it is a tangent, remaining things will be same. Here also, the same thing, same derivation get continues, AC and BD. Here, only one assumption, that is C. What is that width? Width is equal to 2 into AC, the same thing. BD is, again here also we have calculated BD and AC, height, width, and this is AC ends here and this is width, BD. So measurement of tooth thickness is done by, one is using gear tooth vernier calipers, then using constant chord method, that is the chord will be remaining constant, then base tangent method. So here for the base circle we will be drawing a tangent and the profile is involuted so that the rest of the profile of the gear can be calculated. Then another thing is by comparator method. So this is a fourth method of measurement of tooth thickness for a gear. Specifically speaking, whenever we will be measuring tooth thickness means we will be calculating the width of the gear as well as depth of the gear. Only two parameters, one is width and another one is depth, and the correlation depends upon the parameters. If there are more parameters, then it is having more accurate. If there are less parameters, it is having less accurate. Sometimes there are only parameters like pressure angle. In such cases, it is so accurate, everything will be expressed in terms of pressure angle. That is what we have seen for the base tangent method. The shift what we have calculated, the shift will be in terms of phi, that is pressure angle. So delta is equal to tan phi minus phi, that equation. In such cases, that is very eminent and it is very accurate. So if we know one parameter, then rest of the parameters can be measured. Most of the cases in the gates, number of teeth, it will be vary from teeth to teeth. Vary from teeth to teeth because of some proportion of module. In design calculations you have seen it is round up to the next digit. Like that, the same thing, the teeth may vary. So the first method, gear tooth vernier calipers, it will give only for one teeth. You will be calculating only for one teeth. Next methods, constant chord or base tangent, that will give for number of teeth. In that cases, we will be calculating for whole gears. That means it can have up to 4 teeth. The effective teeth will be calculated. Here, comparator, as the name itself indicates, comparator, it is an instrument. So just we will be directly obtaining the value. David Brown was invented this thermometer, hence it is called as David Brown tangent comparator. Why tangent comparator means? Because it will work based on the principle of base tangent method. So here the theoretical reference calculation is base tangent method calculation. You have to consider width and depth of base tangent method measurement of gears. That is an important thing here. So let us see what is the operator setup. Simply there are two things. One is fixed anvil, another one is movable anvil. So you will be adjusting like a tangent. So this is a base circle. In the base circle you will be drawing a tangent. It is a base tangent, and you will be adjusting these things, movable and fixed anvil, towards the tangent. The teeth will touch and that will be in contact with up to the tangent point. So there is a contact of fixed anvil, here there is a contact of movable anvil, and there is an adjustment here. What you need to adjust? You need to adjust a setting. What is this setting? This setting you will be adjusting using slip gauges. So it is a distance set. You will be calculating what is the distance to be set, and that distance you will be calculating in theoretical calculation. After that you will be adjusting the desired value using slip gauges. So this will be adjusted, and after that the distance between movable anvil and fixed anvil, this distance will give you what is a base tangent depth. What is the base tangent depth? And this is as per this, what is that? Comparator. So it is a instrument value. What is the true value? True value will be using theoretical calculation. You will be taking what is the true value, and if you take the difference, that difference will be giving you the total error. The total error. If the error is 0, the instrument is accurate. If the error is not 0, instrument is not so accurate. Sometimes there might be deviation also. Here we need to set in a correct fashion. We need to adjust the spacing. We need to adjust the slip gauge's length here using this head of the screw. Also we need to ensure that the anvil must touch the tangent. That's why the name base tangent method, because it is using base tangent. Also micrometer head, the reading will be given, reading will be shown in the micrometer head. For that corresponding calculations you will be doing. Basically you will be calculating error. Error is instrument value minus theoretical value. Instrument value you will get something, theoretical value will get something. This deviation will give you what is the error. So this is somewhat advantage compared to other methods, because it can handle many number of teeth at a time. But the limitation of this is adjustment coinciding with the tangent line. That is the limitation here. This is about comparator method. The next thing is measurement of concentricity. What is concentricity? During mesh of gear, two gear need to have a concentric. If there is shift, it will be a runout. If there is any runout, then the radial distance that will give you runout, and that will damage, that will lose the power. Here concentricity. Concentricity is, it is having the same center. Let us see, they have plotted a graph versus indicator reading versus gear tooth number for a different types of gear teeths. All the teeths must be concentric. If it is not concentric, then again there might be a power loss, again there will be a slip. Because of this slip, the gear may get wear and tear. Particular teeth will get damage. And it is very difficult to achieve 100% concentricity. There is a limitation. What is that limitation? We will be considering the gear tooth numbers as well as indicator readings. And if you just plot, the values will be nearer like this. Then after that, if you draw like a smooth curve, then that should be in within this. If we say that is within this, it is somewhat precision. All the teeths cannot be have the same concentricity. There will be a deviation. So that deviation should be small. That should not exceed the limit. Otherwise, what happens? Wear and tear may happen. Sometimes larger area contact, sometimes less area contact. Because of this, power transmission will be lost. Again, that will lead to runout problems in the gear. So what is the variation here? That variation will be the function of eccentricity. Eccentricity means there is some offset with the center. We will be calculating. That is nothing but a concentricity. Concentricity is not a big parameter. Moreover, runout is a big parameter. runout itself will be telling indirectly what is the concentricity in gears. So most of the cases concentricity is measured like this only. It is an average curve. There is no such formulas, just it is a normal distribution. Then let us see the measurement of profile. What profile? It is an involute profile. What is an involute? An involute is, it is similar to teeth manufacturing in milling. First what we will do is, first we will be forming one teeth on the cutter, then after that it is indexed. It is somewhat like this. First one teeth will be manufactured for the circle. This is a gear. Initially it will be like this only. Then after that one teeth will get manufactured in milling. Then again it is indexed. Then other teeth. So this is an involute profile. This rotation is involute profile. And here the transforming this distance is here. See here it is given. So this distance is making involute profile. It is being indexed. Let us see what happens during involution. So I will consider a tangent AT for an involute profile. So this is C, and this distance I have to calculate what is AC1. It is a transformed distance. Earlier it was something else, now it is being indexed. Earlier it is like this, now it is indexed. Again next, this is a next teeth, this is a first teeth. First teeth is being indexed. Already it is being cut and finished. Next it is indexed. It is just like having a lunch in a group. The first person will be serving. Then after that you will be moving. So instead of moving linearly, here it is a rotation. First teeth manufacturing over, then again it is indexed. How much angle it is to be indexed, and again milling calculation will be there. Then after that the second person will be coming and second teeth will be manufactured. Then third person, third teeth, fourth person, fourth teeth. Like that it is being rotated, indexed. And this is a starting point of involute, that is a first teeth point, and this is a second teeth point. So I have measured angle as a phi 1, pressure angle for the teeth 1, phi 2, pressure angle for the teeth 2. Basically pressure angle, theoretically speaking, it should be constant for all teeths. That is a condition we will follow here. Let us see what is the thing. So I need to calculate what is this H1. That means involute, how much distance I have to move. H1, H2, H3 I need to calculate. H1 is equal to A into C1. It is also equivalent to this arc A dash. This arc distance. So what is this? What is the length of the arc? Length of the arc is S is equal to R theta. First PUC. S is equal to R theta. Here what is R? R is radius of base circle. What is theta? Theta is phi 1, pressure angle. Then H2, similarly H2 is RB into phi 2, how much it is being indexed. Similarly, if I write it for n teeths, Hn will be equal to RB into phi n. So this is an equation for a nth teeth involute profile. So like this it will be continuing. And how to measure this? Actual measurement will be there. Actual measurement is done using gauges. So we will be using a gauge. Directly we will be placing the gauge on the teeth. Directly it will give the actual reading. So error will be calculated. Error will be equal to actual reading minus theoretical reading. Here actual reading is instrument. Instrument is the same thing, gauges reading minus theoretical. Theoretical is this calculation. This will give you error. And this is about how to measure profile. Profile is involute profile. It is just a profile of gear during indexing. So this